Hello there. I hope you had a good day. Today we are going to do some machining in FreeCAD. I'll be giving you some examples on how to use FreeCAD for creating profiles. That's machining profiling, mainly taking off parts. Then we shall look at pockets and then some bit of drilling. I'll be using this part you see on the screen that I had a demonstration on the last video. I'll put the link to the video, a link at the bottom of the video. So if you want to get this part, just go back to that video, watch and see how you can make it. And then we shall use it for, you can use it for machining. So let's go ahead and get started. Now, for you to be able to machine, you'll actually need some machining tools, yeah, for you to be able to create Gcode that is going to work on your part. Now, as you can see in here, we have different sizes of slots and then also have some holes. So my suggestion would be go to a site like McMaster or any other machine tool production company. So if you go to a site like McMaster, you can look out into under machining. Let's go down. It's under fabrication machining. You can get the drill bits and then the end mills. Where are the end mills? So here are the end mills. I'm going to use metric. The reason I'm using metric is the post processors in FreeCAD for CNC are actually in metric. You can do, make your adjustments in Imperial, but FreeCAD will actually convert them in metric. So it's better you use metric so you avoid any errors. So what you'll do is you'll come in here, select your tool, select the size of the tool, and then go ahead and select, depending on the number of flutes and what you want, go ahead and click on that tool number. Now, in order to get things like feed rate and all that information, you'll have to click on product details and sign in. But to get the dimensions of the tools, you can actually just go ahead and download the PDF. And this will give you the dimensions of the tools. So we shall be using this in FreeCAD, where you determine the cutting length, the diameter of the tool, and then the length of the tool. Now, let me get an image here. Just give me a second here. I'll get an image. I'll show you, which can make this really simple. So when you're looking at a cutting tool for values to enter into FreeCAD, you're going to be interested in these dimensions, D1, D, L, and L1. So if you go into FreeCAD, you change, these are the things you need to do. Go to Path, go to Edit, go to Preferences, make sure your units are in metric, small parts, and CNC. Make sure you change that to that and then click on Apply. After you're in the Path Workbench, go to Path and then go to Toolbit Library. From here, you're going to go back to this site and get whatever tool you want. For example, if it's a 10mm tool, you'll come back to FreeCAD and say create a tool bit. Now, FreeCAD already has templates of the most used machining tools. And in this case, if your tool is an end mill, you select that as an end mill and click open. And then create, let's create one of a cutter that is 15mm, right? a cut that is 15 millimeters. You click on save. Then you double click on that, and then you can, let's just give it that 15 millimeter cutter. And then you determine the cutting edge height. So if you go back to our image, L1 is the cutting edge height. So we could take it, let's say, as 30 millimeters, right? So we can leave it at 30. If it's a 15 millimeter tool, you change the diameter here to 15 millimeters. Then the length of the tool is L1, yeah? So it could be 100 millimeters, 60 millimeters. It depends on what you're going to get from the data sheet that the manufacturer gives you. So for example, if this is 70 millimeters, you come to your tool and put in 70 millimeters as the length. You see that? And then the shank diameter is D1. In most cases, the shank diameter is the same as the diameter of the cutting tool. So you can come here and put, since it's a 15 millimeter tool, and put 15. And then go to attributes. The number of flutes, you can go ahead and put, if it's a 4-flute tool, for example, you can go ahead and put in, this is a 2-flute tool, so you can go ahead and put in 2 flutes. And then if you have the details, for example, of the chip load, you can go ahead and enter those attributes in there, right? And then click OK, and then click Close. So after you do that, we are going to start our machining operations. So you'll click on this, which says Create a Path Job Object. And then make sure you select the body you're going to machine and click OK. Then go to Tools. By default, FreeCAD always adds 1 tool. So go ahead and click on Add, and then add all your tools you're going to use. Like, remember that I showed you how you're defining the tools. For example, the 15 millimeter tool, I already have my tools defined that I'm going to use. So you go select them and then click on Open. After you do that, you can remove that default one and then give your tools numbers. So for example, this could be tool 1. I'm going to start with this as tool 1, and then I'll go to this as tool 2. All will depend on how you're doing your stuff. So I'll do that as tool 2. Then 10 millimeters will be tool 3. And then I can go ahead and give these any other number. So tool 4, tool 5, tool 6, sorry, tool 6, and then tool 7. Okay. Then you go to setup, leave this on the default values, or depending on your raw stock that you're going to use for machining, go ahead and enter these values by measuring the stock using, let's say, a vernier caliper, and measure the stock you're going to use, and then input these values accordingly. And then we go to output, go ahead and define, right? Where you're going to save your files. For example, I'm going to save my Gcode. Let me save it in this folder. So I'll call this flange.nc. That's where my Gcode is going to go. And then the processor. If you're using any of these machines, go ahead and select that. But I would suggest use Linux CNC. Because that is heavily supported, and you can always customize it to fit your machine. And then select the G codes that you want to be added. By default, make sure you select G4. Most machines have G4 as the default work setup. So after you have all that, go ahead and click on OK. Right? So you should have an entry tree like this. So we are going to start our operations. So the first operations is going to be a profiling operation. So go ahead and click on this. This will be profiling. I'll profile using the 12. I'll use the 12mm end mill. Go ahead and click on that. And then under that, you're going to make sure you define profiling outside, since we are going to work on the outside part of the tool. And then you can leave the rest as default, since we are only going to cut off the outer part. And most likely, we are going to just take off the 1mm extra we added. You can see that. So after you do that, click on apply. And then, okay, you should see our profiling part. You can always test and make sure everything is working okay by clicking on the simulator. Make sure you select your operation and click play. You can see that profiles in 2 steps and removes that extra material. Let's go to the second operation, and that is going to be a pocket operation. I'm going to remove the materials in these corners. So go ahead and click on pocket. This is the tool for pocket. And I'll be using a 10mm end mill. Never use a tool that is bigger than the radius that you're going to cut through. So I'll take a 10mm end mill. I'll use flood coolant. Depending on what your machine uses, you can use mist, but I'll use flood coolant. And then the cutting pattern, I'll select a zigzag with offset. Leave the rest as default, but change the step over. Depending on how you want to do it, if you want to have a smooth cut, I would take this to something like 10%. Okay, so I don't have just round circles onto the surface. So after selecting 10%, select on use outline, then go to base geometry and select these lower faces. Click on that lower face, add, click on that, add, click on that, add, and then click on that and add. Okay, so you have your 4 faces, and then you can click on apply, and then it will create the profiling path. We can go ahead and click OK and simulate it to test. Let's see what happens. Okay. We can remove that material. That looks okay. If these look like more steps to you, you can always reduce them to what you think is optimal. That's all what machining programming is all about. So we have removed the materials in the corners. So I'm going to create another profiling path that will come out and clean out these corners so they are smooth. So go ahead and click on cancel. And then we're going to create another profiling path. So make sure on our operation, click on profile. We shall still be using our 10mm end mill. We shall use our flood coolant. We shall be profiling outside. And then what we're going to do is we're going to go to our geometry and then add these faces. So 1, 2, all these, select these. Let's add that, turn our part over, select this, add, turn it over, select this, add, turn it over, and then select those. And then add, right? If make sure you've selected everything, you should have, I think, 16 faces. So 3 for each corner. So 3 times 4, that will be 12 plus the 4 faces. That's 16. You can count them. They're 1, 2, 3, 4, 5, 6, 7, 8. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yep, we have 16. So go ahead and click on apply, and you'll see a profiling path. Let's go ahead and simulate that, just to be sure everything is working okay. So click on that. To make it faster, let's remove that and just go to the profiling. Yeah, that looks okay. We can add back the pockets and we see how the profiling works. Okay, so looks like everything looks fine. So let's simulate the whole operations and we see. Okay. So whenever you're creating these machining operations, make sure your operations won't cause a tool crash. Start with a process that removes most of the material while you go inside and create your part. So this looks perfect. Let's go ahead and go to another operation. So we finished that profiling. We are going to now create a pocket operation, and we're going to work on the 3 inside slots. So click on the pocket tool. We shall be using still a 10mm end mill. We are overloading that. So the cut will be zigzag out, step over. I'll take 10 again. Just like that. I'll take 10 again, and then I'll select use outline. Coolant, I'll take flood coolant again. Then we can go to our base geometry. Just make sure you clear out that. Select this base, add. Select the base, add, and then select that base, add. So let's go back to our operation. I think everything looks okay. Let's apply, and we see what we come out with. Okay, our code has been generated. Let's go ahead and click OK. Let's go to simulate. Let's remove all these operations and we only work on the last one so we can move through this faster. Okay, we are slotting that first hole. You can see 2 passes. Go to the second one. And then the third one. That looks great for me. So go ahead and click on cancel. And then we're going to create another slotting operation. At this time, they are going to be the smaller holes, and we shall change our tool to a 6mm end mill. Still, our cutting will be zigzag offset. Step over will be 10. We shall be using the outline. We go to base geometry, select that, add, select that, add, select that, add. Make sure we are selecting the bottom, select that and add. Okay, so let's go back to our operations, check everything is okay, click apply, click OK. Let's go to the simulator and check all these and just leave those last slots. Always test to make sure the operations you've applied actually work. And as a step of caution, CNC in FreeCAD is still on an experimental level. So once you simulate this and it works out, I would suggest check the code and compare with the operations on your machine to just make sure the code matches, the Gcode matches the code that your machine is going to use before you actually run this code on your machine. Okay, so this is still running. Okay, we are done with that operation. Let's go ahead and close that. So we're going to go to, I think, the last operation, which will be drilling. We shall be drilling these holes. So click on drilling, which is that. Hold on. Let's go to our operations. Let's first recompute this. Then recompute this. So go operations. Okay, so let's go to the drilling operation. Now, if you go to drilling operation, FreeCAD will actually select for you the holes by default. As you can see, our holes are 10 millimeters diameter. So once we come to the operation, we need to use a 10 millimeter drill, not an end mill. We use the drills for that. Now, you have an option of peck drilling or dual drilling. So we shall select peck, and then we shall select the extended depth. So if you look at the tip of the drill, drills always have a sharper tip. But remember, we want to go through this, it's a through hole. So we shall select extend 2 times the drill tip. Okay. But I see there's a bug in FreeCAD. I'm just not sure of how to do it. If you drill, still it's not going through, but you can always edit this in your Gcode by increasing some more Z height, and then the drill will go through the hole. But go ahead and select 2 times drill tip. Make sure you're selecting a 10 millimeter drill. You can always use flood coolant on that drill. And then after you do that, go ahead and click on apply, click OK. Let's try to simulate this. I think one of these drill operations was wrong. Let's just check this, and I delete out this drill operation. This wasn't needed. Okay, so we only have one drill operation. Let's go back to the simulate and select all these and run that. Perfect. So let's go ahead and select all our operations and then run them. Just make sure our part is being machined the way we want. So we are pocketing those 4 ends. You may have other efficient ways of doing your machine operations. This all depends on how familiar you are with your machine. So, but the path you always take depends on how efficient you're going to clear out the material on your CNC tool. This is the quickest I would come out with. So, yeah, so that's going through. We are going to go to the 3rd slot. Looks good. It looks perfect. So just to be more caution, I've worked with CNC machines, and you can easily break some tools if you've done the wrong coding. So just make sure when you're taking this code and you've designed it in here, check it out, check the codes, reduce the feed rates on your machine, and just maybe try a demo cut to make sure everything is running okay before starting to cut metal. The last operation we are going to have is the drilling operation, and then we shall go and look at the Gcode. So, okay, so in regard to drilling, you can see it did the holes, but they are not through holes. So on this last drilling operation, you'll just have to always edit your Gcode and then optimize it. And with here, you just have to add the negative Z value and increase it so it goes through. So that's it on here. So we can go ahead and check. Let's go ahead and move this here. Let's go ahead and check our Gcode. So if I come to operations, let's see here on the post processor, and then click on save. We can expand this and we can look at our Gcode. So this is the Gcode that FreeCAD is going to generate, and you can always edit this to match the operations on your machine. So you may also have some questions regarding your tools, like the feed rates. So you can always come to Path, go to tool. Actually, you can always click on the tool itself. Maybe I would just make that simple. You click on the tool itself. You can specify the horizontal feed, the vertical feed, and then the spindle speed. Yeah. In most cases, these cutting tools like facing, you're going to use, depending on your tool, but you're going to use spindle speeds of sometimes 500 and above, right? So you always define your spindle speeds in here, your feed rate, and your horizontal, both horizontal and vertical feed rates. And then if to increase on the speed of machining, you can always also determine the rapid speeds to just be cautious, right? That's why you say by default, FreeCAD, just make sure you don't edit these to avoid any crashes, but you can always adjust your rapid speeds, but I would suggest leave this at its default. So you find your spindle speed, let's say 500. If your spindle moves forward, you can click on the forward move, which is the default in most cases. So that's how you can define the speeds and feeds for your tools. That's it. I hope you have a good day and happy New Year.